this idea of giving developers more bites at the apple as the critical requirements for being able to get innovation to your production environments as quickly as possible.
Hi, this is Yosipin Bhartia and welcome to TFR Let's Talk. Today we have with us Shawn Ahmed, Chief Product Officer at CloudBees. Shawn, it's great to have you on the show.
Thanks for having me. I'm glad to be here.
It's my pleasure to host you. Let's quickly talk about CloudBees. What do you folks do?
Well, CloudBees is originally and always been known as the Jenkins Enterprise company. We're the largest open source contributor to the Jenkins project itself over the last 14 years. That's how we started, and today we are a DevOps and a DevSecOps platform company that contains all the capabilities that typically DevOps organizations, developers use, and operations use together to build, deploy, release, secure software, and the software development deployment chain. So we have been built on top of Jenkins, and today, support customers both that are using and building software on-prem and as SaaS as a deployment, cloud native, as well as also traditional application to cloud native application and everything in between.
When we look at Jenkins, traditionally we associate it with CICD or CI and CD, depends on how you folks look at it. Can you talk about the evolution of the whole CICD and then how things have evolved over time, where it's less about CI and CD, and it's more about platform or automation things for DevOps or developer teams?
It's a great question because DevOps has been quite a moving target, I would say, in terms of sort of its evolution from its original humble beginnings of extreme programming principles and development style that encouraged a lot of check-in very early on the code. Testing and build times that were added on into the pipelines and automating essentially everything you do that happens after you actually commit your code. The idea being that you want to build it, you want to test it, you want to scan it, you want to deploy it, you want to have as much feedback as you can as fast as possible back to the developer about the quality of the code and how it works. But it has grown from there, right? We've also seen ops organizations that become far more involved in the process when you think about sort of releasing the software into production. What kind of steps does it need to go through? How governed does that process need to look like? It's not just about deploying a binary out anymore, but the system sort of grew from we're doing CI/CD to we're also releasing software. But growth from there happened, and then you have this evolution of DevOps becoming DevSecOps, with security shifting also left into the DevOps sort of platform itself, and the idea that you have to securitize code, whether that's you running SAST scan, DAST scans, binary scans, whether you're running infrastructure scans, you want to make sure that the code that you're building is secure and tested before it actually hits into production as well. So a lot of scanners and growth coming into that system as well, or into the actual pipeline, and the idea being that we're securing now this pipeline at its inception before the code goes to production. And that sort of have been like largely the macro level evolution of we're just running CI workflows to now we're managing the entire software development lifecycle all the way through down to the release and ultimately observing how that code is operating. And I think the last frontier, I think for a lot of folks is in today's world is also to progressively deliver software. In other words, being able to move into sort of using feature flags and those types of things to sort of get, code into a small user's hands and testing it very, very quickly, all in an effort to be able to get fast feedback cycles back to the developers about how that feature that they have built and released is actually performing, and progressively delivering it out as the performance or anticipated behavior of the feature is meeting or exceeding its sort of goals. Then we progressively deliver it to larger audiences. That has sort of made, I think, in many ways, organizations be able to do things in a much faster way than, for instance, blue-green deployments and things like that. So this evolution that we've seen has been pretty constant over the last decade, I would say.
And since we are talking about evolution, I also want to talk about Indolent teams and the culture. Before whole cloud native, we used to have silos, network teams, security teams, of course, storage. Even today, we have, I call them soft silos because, you cannot have the whole unicorn approach. And even in the cloud native world, now we are talking about a lot of practices, principles that sometimes seems to overlap or sometimes they seem to compete and there seems to be some gap. You talk about security and then we talk about observability at the same time, and there are a lot of overlaps that happen there, which means that cloud native sometimes becomes more complicated than a single lab stack in some cases. How are you seeing this evolution where we love to talk about shift left movement? A lot of things are moving to developers pipeline, but developers should be free to write business applications which are innovative, then operators can deploy them. So how we have seen that transformation, and also how do you see some of these practices where organizations are not overwhelmed with having these separate silo teams specializing in security, observability, of course, SRE. Then we can talk about the whole CI/CD pipeline or automation. How are you looking at things, and how is cloud be kind of making things simpler and easier for customers?
In many ways, like the underpinning, I think, of the evolution of a lot of the DevOps or DevSecOps platform out there begins really with this idea that you try to put the developers in the center of the universe. As they write the code, you want those developers to have as many bites at the apple as they can get, because there's one constant you can't change, and that is that the day has 24 hours in it. And it's within that time that you're writing code, building it, testing it, deploying it, releasing it. And you want to ensure that the developer has as many opportunities during that time to do what they do the best, which is to code. And so I think that as that shift left movement that you talk about started occurring, more and more DevOps teams started evolutionizing their practices. And I think a very popular way of thinking about it today is this concept of a platform engineering team, which consists of a much broader cross-section of team players that are all ultimately responsible for building and releasing and observing and maintaining the software in production. And as you see these platform teams come together, the demands that they have traditionally had has also then evolved to say the platform has to be something that all of those people can actually collaborate in, that they can bring the very best types of policies, controls, mechanisms, processes, and be able to put them into one place that the developer can sort of be able to jump into and have very easy access to the golden paths required to essentially be writing code on Monday and releasing it on Friday. And that's the mapping that you're trying to do with this platform engineer. And what those platform engineering teams then typically end up doing in many ways, as we see with our customer base, is look for DevSecOps platforms that will accommodate the tool choices that all of these team members have, and ask themselves the question, how pluggable is this platform that exists out there that we can use? Can we all sort of collaborate to generate and create that software development sort of meta pipeline on top of all these tools that we use, where we can express the unique requirements that we have towards that software development process that is unique to our company. And that's sort of the challenge that we have ahead of us, is for these DevSecOps platforms to continue to evolve in such a way they can accommodate the requirements of these types of platform engineering teams. So in summary, I would say it is the combination of that evolution of the teams, its practices, that have also therefore influenced in large part the direction of the DevSecOps platform to accommodate.
Now let's talk about the acquisition you folks made recently, and how does it fit into the discussion we just had about making things easier for teams?
This idea of giving developers more bites at the apple as the critical requirements for being able to get innovation to your production environments as quickly as possible. What you really then have to do is you have to sort of evaluate where is time being spent. And many studies have shown over time that developers on average end up being able to only spend roughly about somewhere between 20 to maybe 30, 35% of their time actually coding. So the question you ask yourself is, well, where is the rest of that time going? And very often, many other studies will say almost as much as 17 hours a week, or up to about 41% of the time of developers are often spent in a week on things like bad code and or tech debt retirement. And when you think about sort of those types of tasks, you wonder, where is that time going? What are they doing during that time? And you could have builds running for multiple number of hours. You can have test plans that have 50 tests in them, or 20, 30, 40 tests in them, and you run through them. So we got maniacally focused on two things. So how can we reduce sort of the time spent on non-coding activities for developers? And the second thing we got really focused on, what is the role of AI and machine learning in that process? How can we apply some of those principles to be able to give more time back to the developer to do what they want to do, which is to code? And we found that a tremendous large amount of time was being spent in what is known as testing, and a test failing, and then triaging and finding out, why did my code fail? Why did the parameters not get met? And trying to figure out what needs to go back and change in the code in order for it to pass its tests, and triaging all of that. And as we started looking around, we saw this very innovative company that really was pioneering the use of AI and ML for QA, and in particular test. And one of the things they were doing was, they were saying to themselves, they said, look, you might have 10 tests that are going to run, but if we can draw relationships between the code changes that you're doing and the types of tests that will fail, we'll start evaluating and looking at those tests and see which tests are typical to fail. And it would learn that behavior, it would learn those associations, and say, you know what, if you've got 10 tests and we know that it takes 2 hours to run through them, test number 10 is going to fail for sure, but the first 9 are going to pass. Then the question is, why do I need to run the first 9 that take up most and bulk of the time? That is wasted time for the developer. Now, if you can aggregate that savings for hundreds of developers in an organization, 1,000, 10,000, we've got customers with upward of 30,000 developers. If I can save each one of them that amount of time, how often would that developer then be able to go back and take yet another bite at the proverbial apple, or be able to go code and fix something and be able to save time and get back to innovating? With that in mind, we looked around and we saw Launchable doing some extraordinary things with very, very interesting customers like BMW and so on. And we found that they were passing and creating sort of these very intelligent predictive test selections onto the developers based on those code changes, and thereby often reducing even time spent on test runs to run by up to like 80%, 70%, being able to give that time back to the developers. And we thought to ourselves, that was a very, very innovative way to be able to run AI and ML for a very specific use case inside the software development pipelines. And so by acquiring them and integrating them into our DevSecOps platform, we think we have a very unique value proposition for DevSecOps teams, but in particular developers who are running tests on the software code, to be able to get back to coding very, very quickly.
I mean, there are different, depending on which camp one belongs to, there kind of, skepticism around Gen AI. But I talk to a lot of folks who are using it in production. So it has its own very niche, like Copilot is a good example where you can get a lot of things. As a journalist, even we use, some of these but we use it to get a lot of base work done, nothing, it's more or less like the information which is available to put it in a format then which somebody will hire a low-level developer or low-level writer, to get all that thing done so we can look at it. How are you seeing the usage of Gen AI or things like Copilot, which is actually helping teams. Also, we are also hearing a lot about people getting worried about these tools taking away people's job. So can you just address that part, that realistically how much adoption you're seeing and what does it mean for teams?
There's a lot packed in your question there, so I'll try to unpack it a little bit, so I can answer it, hopefully as clearly as you would expect me to. I'll begin by saying that I think large language models and OpenAI tools like Copilot, Devin, and others, AWS, Amazon, Q for developers. I think all of these large language models are doing tremendous breakthroughs with regards to when it comes to the core task of generating code. Now we can ask questions about the quality of that code. We can ask questions about whether or not they are assisting developers in the way that developers want. But if I just see sort of the usage, even in my own organization and within my customers, I would say that everybody is saying, look, when it comes to code generation, this is incredibly valuable. And I think that this is one area where there's no reason for us to sort of question the value anymore. I think it's pretty clear. The broader question, though, is how do you apply AI and ML in everything aside from coding, right? Everything that happens afterwards with the code. And this is an arena where I think a lot of folks are grappling with what is the right way to use this technology there now that you have the same pipelines that you had before. You have more code coming through them, some in large part being completely large language model or AI generated with some review from developers themselves. But we still have the same amount of time that we have to go through. And that's one of the key areas for why we asked ourselves the question, how do you answer that onslaught so that you can still keep the sanctity of those pipelines, the code, and everything that ultimately ends up going into production? And that's the second part of my answer, I think, that you were talking about, which is it's much more about understanding what the job to be done is and being very thoughtful about where to apply it, where you can get the greatest value out. And I think that the key word I typically use there is a use case. What is the right use case for the application of such technology outside of coding? And that's something that we haven't seen as broadly being, applied and or found valuable by the market, and questionable with regards to sort of is just text generation enough to help solve some of these issues. And this is where I think that the extension of RAG models, machine learning, agents and transformer type technology to combine in order to focus on a very specific developer flow like QA, like testing, would be a very, very specific use case that we think it could add value to. So we say, okay, let's go deep in that area and specifically focus there first. It's like an anchor use case or a job to be done. Let's see what the right use case there is so that we can help the DevOps team, be able to get through it. And that's where things like a predictive test selection, it becomes a critical use case, or test failure triage, or identification of flaky tests. Those are the types of things the developers are going to grapple with after the code generation piece. And that's why we decided that this is one of our key focus areas first to begin with. And we'll continue to do that to answer your third part of the question, which is, what do we believe the use of this type of technology is going to be in the future? I do not want to be able to jump in and say we know the definitive answer to how all of those things are going to be used in the rest of the software development lifecycle. We have to actually observe and see where those pains come and identify the right use cases and apply it there. There's no sort of just implement Copilot and you have resolved all issues in the world. So that's probably the best way for me to, I think, answer that question.
What kind of customer use cases you are seeing where developer, of course, the announcement is recently made, where you feel that there's already a lot of demand and hunger for AI assisted the whole testing, because that does, when we talk about automation, it just add another layer to help teams. So it actually saves their time there. So can you talk some use cases that you're seeing in the market where you see, hey, these are the use cases where folks will be leveraging this combination of, Launchable and CloudBees?
I think if you think about any company out there that's using any kind of CI/CD tool, Jenkins in particular, obviously extremely popular in the market. Out of, say, think something like 26 million or 30 million developers out there in the world, depending on which figure you're thinking about, more than 40% use Jenkins and have Jenkins pipelines that software goes through. And I think a lot of those pipelines today are running in the same way that they were running before, but now you've got code coming through them. So I think that all companies are asking themselves the question, with more code coming through from tools like Copilot or Amazon Q and things like that into those pipelines, how do we have to handle that in the back end of it? So what I am starting to see customers, to answer your questions very specifically, is starting to see the identification and opportunity of applying specific areas or use cases where this type of technology could be applied. Now, obviously, QA is one very big place. The other is just triage of pipeline failures. If you think about the fact that pipeline can fail for any number of reasons, often what ends up happening is you have a pipeline failure and now starts the triage to figure out why it failed and who's to blame and where do we need to go fix the problem. And you see repeated behaviors around there. Now, the interesting thing for a company that uses Jenkins is sort of the orchestrator of all of these tools in your tool chain, from your code repository all the way down to automating the actual release itself. So all the tools you're automating beneath there, they're all generating tremendous amount of data. And if you're automating them all via Jenkins, what happens? Jenkins collecting incredibly valuable information from all of these tools that it can aggregate back. The question now is, if you were to use things like machine learning or AI and models to identify clusters of DNA behaviors that lead to certain, sort of failures, over time, that model should start becoming self-soothing. It should become more like an agent. The idea that you no longer have to start a build at night, right, with tests running overnight, and then showing up at the office at 8 o'clock in the morning and something failed, and now you're spending the next 2, 3, 4 hours speaking to people on the phone, getting on Zoom calls to figure out what failed and what do we have to go fix. That should be able to be largely triaged by AI and be able to provide very quick sort of resolution paths to the DevSecOps teams and be able to say, hey, look, here's some of the ways that this problem can be solved. We've seen this before. This is how it failed and why it failed. And here's typically the fixes you can apply wherever those might be. And would you like me to generate a ticket for you, and or even go as far as, do you want me to make the code change on a new branch for you and test it again and see if it works? So that's another area that we see these things happening. And the final place where I see a lot of questions being asked and how it can be used is really on the release side of things. This idea that we want to progressively deliver software, but we also want to observe how the software behaves as we start releasing it. How smart and how self-soothing can that be? In other words, is there an opportunity for us to be able to say, release and forget? In other words, we released it, but we have the ability to be able to run experiments on that release before it hits our entire population of users. And the progression from, I released a feature where only 2% of my population of users received it, I observed the behavior, found it's inside of acceptable parameters, then release it to the next 5%, then release it to the next 10% until the whole population has it. That type of progressive delivery is like sort of a dream scenario that I think a lot of customers of ours are coming back and saying that would be another area where we think AI and ML can play a part for us, together with feature flagging our software, because we really want to achieve progressive delivery. So that's three areas where we're seeing a lot of progression. And why I'm so excited about Launchable acquisition is that they have already solved, in large part, this challenge for the QA area. And the core principle of the architecture is applicable in these two other scenarios as well. So we feel like CloudBees have a very unique opportunity to work with our base of Jenkins customers, as well as platform users of our brand new platform we released in November, to be able to roll these types of capabilities out, and you have to make little to no changes in your current pipelines. That's the beauty of it. Little to no changes to your current pipeline. You just have to call out a small tag from your pipeline to say, run through Launchable's technology and give me the best advice on how to go run my tests. And then it will do that part for you. Now we can extend that sort of architecture into both triaging of the pipeline failures and then ultimately into progressive releases as well. Very quickly making an opportunity for our users to be able to get tremendous amount of time back to the developers to release innovation and sort of beat that 24-hour cycle that is the old father time that you cannot change because it's physics. So I hope that answers your questions about sort of where those opportunities resides and how we think we can uniquely solve those.
Shawn, thank you so much for taking time out today. And of course, not only talk about this acquisition, but the wider ecosystem and how AI, Gen AI, LLMs are having a realistic impact outside all the hype cycles. Thanks for those great insights. And I would love to have you folks again on the show. Thank you.
Well, thank you for having me on. It was such a pleasure to be asked to be on your show and be here and be able to tell the story and be able to tell you why this is so interesting for us and how we think we're going to make a difference in developers' lives. Every opportunity I have to do that, I get very excited about. So this is a great show. I've watched it many times before. You do a tremendous job for your viewership. So thanks for hosting us on the show, and I hope to be back again soon.